Hello everyone, welcome back to Joe Micros here. If you're new here, I'm George, and then today we are going to dive into one of the most powerful technique in spatial data science, that is spatial autocorrelation analysis using ArcGIS Pro. So have you wondering ever looking at the map and then wondering whether high or low values clustered together, or whether patterns you are seeing are actually random? That's exactly what we are going to do. And then in today's video, I'll walk you through how to interpret histogram, Moran, Scatterplot, and then the list output, just like the example you see here. So as you can see here, you can see we have the cold spot and hot spot. But what we are going to do today is we are going to do what we call the high and low. That's the spatial autocorrelation, that's the cluster analysis. So we are going to see how things are clustered if we have rich people clustered in a place, or we have rich poor people clustered in a place. And then you can see we have the histogram and then the others. So please grab your data. It doesn't matter which data you are using. So either you are using socioeconomic data, temperature, any data you can use. And then let's explore how spatial statistics can transform spatial numbers into meaningful geographic insights. So quickly, let's get into it. Okay, so first of all, you launch your software, that's your ArcGIS Pro. So if you want to create a new project, you go to project and you click on map and then you create a new project. So the data that you are going to need is you are going to need your what we call the XLS data. That is where that's the Excel data where you have saved your data. So this is the data that I'm using. You can see I have socioeconomic data here. I have under 5 mortality, SHS enrollment, and the non-employment rate. So this is the data I'm using, and you can see we have the district name here. So I have 43 districts here. Yeah, I have 42 districts here. Then you can see I have SHS enrollment, and then they are changed. So this is the data that I'm using, and then this data fall within a certain region. So this is the shapefile for the region that I'm using. So I have the shapefile and then the region inside the shapefile. So the first thing that we are going to do is we are going to link our shapefile to our sheet here. So this is where we can find our data. So if you right click on it and go to open attribute table, you are going to see the data here. So you can see I have all the data here. So I'm going to join the region shapefile to my data here. So to do that, you right click on your region data here, then you go to join and relate. So you can see I have join and relate here. So we are going to add join. So we are adding this sheet to our shapefile here. Yeah, so you can see input table is going to be my shapefile, and then the output field is going to be the name. So what you need to check is you need to check the name of your data here. The name of your data here need to match with the name of your shapefile. So if you check my shapefile here, you can see I have name here. Let me show you. Yes, I have name here. So this name needs to match with the one on the data. Yes, before you can validate your joint. So you can see I have input my name input field here, that's the name, and then the sheet is what we are working with, and then this is the joint field, that's the district name. So I click on validate to see if my joint has matched all the records. So you click on validate here, then you scroll down to see. So here you can see we have joined checking join for join coordinality, that's 1-to-1 mapping. So you can see here 1-to-1 joined match the 43 records. Yeah, so now you click on OK. So if your join is not successful, you get a message that will show you that the join that you did is not successful, so that you go back and then you check it again. Alright, so now I have joined my table. So let's open a attribute table and see what we are going to get in the attribute table. Alright, so now this is the data we just joined. So you can see this is the data we joined with our shapefile. So now we are through to perform our cluster and then outlier analysis. So first of all, you go to your view tab and then you choose your geoprocessing tool. So inside geoprocessing tool, you go to toolboxes. So inside toolboxes, you scroll down until you see spatial statistics tool. So you click on spatial statistics tool, and then you scroll down, then you see mapping clusters. You choose mapping cluster. You can see we have cluster and outlier, and that's the excellent local Moran eye. So you double click on it, and then a prompt will be pop up for you to insert your data. So here I have three data that we are going to work with. So here we are going to work with change of on enrollment, and then changing under 5 mortality, and then changing unemployment rate. So these are the data that we are going to work with. So let's see. Okay. Okay, so let's wait for this one to run. So after that, we can insert our data here, and then choose our variable that we want to map. So first of all, let's make our map hollow, so that any analysis that we are going to do, we are going to see it inside the map. Okay, so let me make this one hollow. Okay, so this is our map, and then now I can uncheck the base map so that you can see the shape here. So this is the shape that we are working with. So this is our cluster and outlier analysis, which we are going to insert our input feature. So our input feature is going to be our Asante region. So this is the data here, the Asante region vineyard. So this is where we save our data. So our input field is going to be first of all, we are mapping with the under 5 mortality, changing under 5 mortality. So that's going to be our input field. And then we have output field here. So here, if you want to change it, you can change the name. And then we have the conceptualization of spatial relationship, which is inverse distance. So if you want to choose the k nearest neighbor, so the k nearest neighbor work in such a way that it's take the property of the known to the neighbors of the known to predict around it. So you can choose the k nearest neighbor. We have fixed distance band here, then we have the others. So let's maintain the inverse distance, and then you check for false discovery. So if you click here, you can see we have checked statistically significant will be based on the false discovery for 95%. So if you check for false discovery, it's discovered that the analysis that you are performing is over 95% confidence. Alright, so now after setting all your variables, then we click on run. Okay, so now you can see we have an output here, which you can see we have our high cluster, high low cluster, low high cluster, and then low cluster, no significant, and then no neighbors. And then we have our histogram here, and then our Moran scatter here. So what this is showing is that if you see where we have the red here, the high low cluster, it means that so this is this one is under 5 mortality. So it means that we have under 5 mortality high in this place, but it's surrounded by a low under 5 mortality. So we have high under 5 mortality here, but it's surrounded by a low under 5 mortality. And then if you see high cluster, it means that we have higher values surrounded by higher values. And then if you see low high cluster, it means that we have low cluster surrounded by a higher cluster. Then the no significant means that we don't have a higher, we don't have lower. So in the middle, that's the no significant, and the no neighbors to is here. So let's run the other one, and then let's see. So after then we will explore the histogram and then the Moran scatter to see what we are going to get. So here what you need to change is you need to change the under 5 mortality to, let's say, unemployment here, and then you change the output to unemployment. And then we have our conceptualization here, our row, and then our false discovery here, which you can click on run. So now we are running our unemployment to see the clusters and then the outliers. Alright, so this is our unemployment here. So let me uncheck this one. Alright, so this is our unemployment here. As you can see, we have our high cluster, high low cluster. As I explained, it means that a low cluster is surrounded by a low cluster, a low cluster is surrounded by a high cluster. So you can see where we have the clusters, and then the whitish or this area are the non-significant area, which you can see it on the table of content. So let's open our scatter, our histogram, to visualize what we have. Okay, so here you are going to see our histogram here, which you can see we have our change of unemployment and then the counts here, and then this is the middle of our histogram, that's the sheet 1, and then you can see we have our mean value here, then we have our median, that is 0.074, and then our standard deviation here. So this is our histogram, which you can add to your analysis whenever you are doing any analysis on your cluster and then your outlier analysis. And also you can check for our Moran scatter here. Alright, so this is our Moran scatter, and you can see we have the R2 of 0.14. So what do you call it, the Z transform shows whenever it's going up, it means that there is a cluster. So this one you can see it has been going up on the positive side small, which is clustered but not significant. So it's a little bit clustered but it's not significant. So the Moran scatter explain if the data is scattered, if it's clustered or not clustered. So you can see we have R square of 0.134. so it's a little bit clustered but it's not significant. So this is why. And then you can see the change of unemployment and the spatial arc here. So the scatter plot explain if the data is clustered or not clustered. Alright, so this is the simple thing that you need to know about our cluster and then outlier analysis. So it's very simple that you can run your analysis after getting all your data together. You can run your analysis and then use your histogram and then your Moran scatter to do any analysis on it. So thank you very much for your attention, and I hope this video was very helpful. Please, if you have any question, just leave it on the comment section, and then please don't forget to subscribe, share and like. Thank you very much.